Good morning, sir.
Good morning, students. In this class, I'm going to explain optics. Optics. There is the various phenomenon such as reflection, refraction, interference, diffraction, polarization. These are the concepts of the optics. Reflection, refraction, interference, diffraction, polarization. These are the various phenomena of optics. When we take this reflection, a ray of light that instant on the surface at an angle theta with the normal draw. This is the normal. With the normal, it will make an angle theta. This is the reflected ray. This is angle of incidence I, angle of reflection R. Okay. Angle of incidence is equal to angle of reflection. Next. So this is valid for all reflecting surfaces. Let us suppose this is a convex surface. On the convex surface also, if the light ray that instant, this is called as a reflected ray. This is angle of incidence, this is angle of reflection. Or if you take the concave surface, for the concave surface also, this is the incident ray and this is the reflected ray. Angle of incidence, angle of reflection. We'll say that. This is for reflection. Let us suppose reflection from a plane mirror. It is a plane mirror, let us suppose. If the object is at a distance of d from the plane mirror, then its image also will be at the same distance. Image also will be at the same distance from the plane mirror. Okay. If the object is moving with velocity v, then its image also approaches the mirror with the same velocity v. If the mirror is approaching towards the observer with velocity v, then he'll observe that his image is approaching with a velocity of 2v. When the mirror is approaching with towards that observer with velocity, towards the person with velocity v, then he feels that his image is approaching with velocity 2v, like this. Image formed by this plane mirror is always laterally inverted, upright. Left becomes right, right becomes left. This is that laterally inverted image will be formed due to that plane mirror. So let us suppose two plane mirrors are inclined at an angle 90 degrees. If the two plane mirrors are inclined at an angle 90 degrees, if the two plane mirrors are inclined at an angle 90 degrees, then let us suppose this is the incident ray. This is the incident ray, and this is the reflected ray for the first mirror. Let us suppose this is a mirror M1 and mirror M2. This is the incident ray on the first mirror. This is the reflected ray from the first mirror. And again, this is the reflected ray from the second. Okay, if the angle between these two mirrors is 90 degrees, incident ray and reflected ray, they'll be parallel to one another. Means anti-parallel. They'll be anti-parallel to one another. We'll say that. Otherwise, if you take these two mirrors like this, if you take that two mirrors like this, these are right angle to one another. If the light ray that instant on the mirror, if the light ray that instant on the mirror, this is the instant light ray, this is the reflected light ray from the first mirror, and this is the reflected light ray from the second mirror. This is instant ray, this is the reflected ray. It will be like this. If the two plane mirrors are inclined at an angle 90 degrees, the instant ray and reflected rays, they are anti-parallel to one another. They are anti-parallel to one another. Okay. Next, if the two plane mirrors are inclined at angle theta, let us suppose two plane mirrors, they have inclined at an angle theta. This is one plane mirror. This is one plane mirror. This is important. Repeated pronouns are there. Bisector it is. It is what? Bisector. It's called as that bisector. It's called bisector. These are the two plane mirrors. They have inclined. They have inclined at an angle theta. The angle between the two mirrors is taken as theta. The angle between the two mirrors is taken as theta. M1, M2, two plane mirrors. Okay. Then anyway, maybe here, maybe here, maybe here. Anyway, if we keep that an object for all the positions of the object, all the positions of the object, if m is equal to 360 by theta is even, m is equal to 360 by theta is even, then the number of images formed, the number of images formed is n is equal to m minus 1, is n is equal to m minus 1. And this is second one. If the object is not on the bisector, object is not on the bisector, then this shall write when the object is not on the bisector, if m is equal to 360 divided by theta is odd, if m is equal to 360 divided by theta is odd number. In such case, m is equal to 360 by theta is odd, then number of images formed, n is equal to m. N is equal to m. Number of image formed will be equal to m. M means what? 360 divided by theta. How to take theta? Let us suppose theta is given as 60 degrees. Then 360 by theta means what? 360 by 60. 360 by 60 will be 6. So it's even number will get. Like then number of image formed will be 6 minus 1, 5. Like that we will take. Now, if the object is on the bisector, when the object is on the bisector, then n is equal to m minus 1. If the 360 by theta is odd number, two conditions are there. One is number of image formed n is equal to m if the object is not on the bisector. If the object is not on, it should not be there. It should be anywhere except on the bisector. In such case, n is equal to m. If the object is on the bisector, n is equal to m minus 1. You have to remember that in the problem, if they didn't mention that object is not on the bisector, they didn't mention. In such case, by default, we have to take object on the bisector only. If they don't mention that object is on the bisector or not, if they don't mention, by default, we have to take it as on the bisector only. That's why if 360 by theta is odd, the number of image formed will be n is equal to m minus 1. First, we will see the problems based on it, then you will get the clarity. Okay, first we will complete that. These are two plane mirrors. These are the two plane mirrors are inclined at an angle 60 degrees. First, this is a different problem. Two vertical plane mirrors are inclined at an angle of 60 degrees with each other. A ray of light traveling horizontally is reflected first from the one mirror and then from the other. The resultant deviation is two vertical plane mirrors are inclined at an angle of 60 degrees. So two vertical plane mirrors are inclined at an angle of 60 degrees. They are inclined at an angle of 60 degrees. These are inclined at an angle of 60 degrees. Theta is equal to 60 degrees. Then what is happening? A ray of light that instants, and it will get the reflection. And again, it will get the reflection like this. This is the instant ray, first reflected ray and separated. Then what is the total deviation, he has asked. What is the total deviation? The total deviation, if you want to calculate, delta is equal to 360 minus 2 theta. If you want total deviation, 360 minus 2 theta. See, 360 minus 2 into, what is the theta? 60 degrees. So delta is equal to 360 minus 120. Then delta D is equal to 360 minus 120 will be equal to 240 degrees. It is. So delta is equal to 240 degrees. Fine. This is. Next, I will show you that. What would be the angle between the two plane mirrors? What should be the angle between the two plane mirrors, so that whatever be the angle of instant ray and reflected ray from the two plane mirrors parallel to each other. What are that? So they should be parallel to one another. Whenever that the two mirrors, plane mirrors are inclined at an angle 90 degrees. When the two plane mirrors are inclined at an angle 90 degrees, then in such a case, incident ray, this is the incident ray, and this is the reflected ray. So incident ray and reflected rays, they are be parallel. In real what? They are anti-parallel. So they'll be like this. So angle should be 90 degrees. Then incident ray and reflected rays will be parallel to one another. Parallel or anti-parallel. These are parallel or anti-parallel. Both of them same we have taken. So this is the reflected ray from the two plane mirrors each other. So that the angle of the incident ray and reflected ray from the two mirrors be parallel to one another. This is the case. Next, we'll see that angle. Right. A plane mirror is approaching you at a speed of 10 centimeters per second. You can see your image in it. You can see your image in it. At what speed will your image approach to you? That I told you. Let us suppose if the mirror is approaching, if the mirror is moving with velocity v, then we feel that our image is approaching with that double of the velocity of the mirror. So velocity of the mirror is taken as v. We are there in front of the mirror and we can see our image in the mirror. If the mirror is approaching us with a velocity 10 centimeters per second, 10 centimeters per second, the image that approaches, we feel that image that approaches with a velocity of 2v, velocity of the mirror, 2 times the velocity of the mirror. So we feel that relative velocity, will say that relative velocity is equal to 2v, then relative velocity 2 into v is taken as a 10. That is equal to 20 centimeters per second. We feel that the mirror is approaching with the 10 centimeters per second. We feel that object is approaching with a speed of 20 centimeters per second. Or with the velocity of 20 centimeters, speed only, with the velocity of 20 centimeters per second. Next. Light bulb is placed between the two plane mirrors. A light bulb is placed between the two plane mirrors inclined at an angle of 60 degrees. The number of images formed will be, the number of images formed will be. See, light bulb is placed between the two plane mirrors inclined at an angle of 60 degrees. The number of images formed are, number of images formed, two bulb images placed. Okay. Theta is given as in between the two plane mirrors. Two plane mirrors are inclined. Two plane mirrors, they are inclined at an angle theta. They're inclined at an angle theta. Then the number of images formed is to be calculated. This is taken as M1. This is taken as M2. This is placed. Angle between them is given as 60 degrees. And 1 point object has placed it. Number of images formed. Number of images formed. M is equal to, first to M is equal to 360 by theta. So M is equal to 360 divided by 60. 360 by 60, it will be equal to 6. So M is equal to 6. M is equal to 6 means what? It is an even number. If it is even number, number of images formed is equal to M minus 1. As it is the even number, number of images formed will be equal to M minus 1. So N is equal to, M is how much? M is equal to, N is equal to 6 minus 1. 6 minus 1. Therefore, N is equal to 6 minus 1 will be equal to 5. N will be equal to 5. Right. number of images formed will be equal to 5. Like one, no more problems I kept it. Two plane mirrors are inclined at an angle of 72 degrees. What did they say? The plane mirrors are inclined, two plane mirrors. These are the two plane mirrors. They are inclined. M1 and M2 are the two plane mirrors. Angle between them is given as 72 degrees. The number of images formed. First, if you want to calculate number of images formed, M is equal to 360 divided by theta. M is equal to what? 360 divided by theta. Therefore, M is equal to 360 divided by 72. 72. The number of images formed. 72, 7 5 are 35. 5 times. M is equal to 5. M is equal to 5. It is odd number. It is that odd number. If the odd number, two cases are there. Object is on the bisector. On bisector. If it is on the bisector, N is equal to M minus 1. If the object is not on the bisector, object is not on the bisector, N is equal to M. They didn't mention it. Object is on the bisector or object is not on the bisector, they didn't mention it. So this is called as the bisector. Object is on the bisector or not on the bisector, they didn't mention. In such case, we have to take that by default, we have to take object is on the bisector. Okay, if the object is on the bisector, number of images formed will be, what is that? If the object is on the bisector. Object is on the bisector. If the object is on the bisector, number of images formed, N is equal to M minus 1. Therefore, N is equal to 4. Number of images formed will be equal to 4. Like this, we will take. Next. Minimum size. A person of height H is there. A person of height H is there. If you want to see his full image in a mirror, you want to see his full image in a mirror, then height of the mirror should be half of the height of the man. Height of the mirror should be half of the height of the man. Right? Height of the mirror will be half of the height of the man, like this. Two plane mirrors are inclined. Two plane mirrors are inclined at 45 degrees each other. If an object is placed between them, then the number of images formed will be, two plane mirrors are inclined at an angle of 45 degrees. These are inclined at an angle of 45 degrees. These are the two plane mirrors M1 and M2. Then bisector, if I take, this is the bisector. This is a bisector. Then these are inclined at an angle of 45 degrees. Theta is equal to 45 degrees. Then M is equal to what? 360 divided by 45. 360 divided by 45. It will get cancelled how many times? 8 times. N is equal to 8. If M is odd number, M is even number, as M is even, the number of images formed N is equal to M minus 1. Number of images formed N is equal to M minus 1. Then N is equal to, M is how much? 8. 8 minus 1. m is equal to 7. M is equal to 7 like this, right? It is given that an object of 5 centimeters tall is placed 1 meter from a concave spherical mirror which has radius of curvature 20 centimeters. The size of the image is. I will give you the shortcut formulas here. So mirror equation. Mirror equation 1 by f is equal to 1 by u, 1 by v plus 1 by v. 1 by v plus 1 by u. This is a mirror equation. Then magnification. Magnification m is equal to minus v divided by u. Distance of the image by distance of the object is called as magnification. Magnification m is equal to minus v divided by u. Or magnification m is equal to height of the image divided by height of the object. These are the formulas, general formulas. Shortcut formulas. M is equal to f by f minus u. This is one shortcut formula to calculate the magnification. Or if you want to calculate in terms of that, if you know that object distance and focal length, this is the formula. If you know the image distance, and the focal length, this is the formula to calculate magnification. Instead of magnification, we may write height of the image divided by height of the object is equal to f divided by f minus u. Like this, we can use the shortcut formula. Magnification is taken like this. What did they ask to calculate? An object of 5 centimeters tall is placed 1 meter from a concave spherical mirror which has radius of curvature 20 centimeters. A concave spherical mirror is there. It is that concave and a spherical mirror. It is the concave spherical mirror. Concave spherical mirror of 5 centimeters and which has the radius of curvature 20 centimeters. Radius of curvature is 20 centimeters. This is called as the principal focus. This is called as the center of curvature. This is at 20 centimeters. Radius of curvature is given as 20 centimeters. Radius of curvature is given as 20 centimeters. This is given as 20 centimeters. Then what is that? Radius of curvature, if they give, that is 20 centimeters. From that we can write focal length. So 2f is equal to r. From that f is equal to r divided by 2. This is 20 divided by 2. So focal length f is equal to minus 10 centimeters it is. Radius of curvature or focal length, they are taken as negative for the concave. So f is equal to minus 10. What we have to calculate? The height of the object is given as 5 centimeters. Asked to calculate what is the height of the image. He has asked the height of the image. Spherical mirror which has radius of curvature 20. The image formed is to be calculated. Then we have to calculate the size of the image. We have to calculate the size of the image. Height of the image is given. We have to calculate size of the image. An object of 5 centimeters placed 1 meter. At what distance they have placed? Distance of the image object is taken as -1 meter. See, they have mentioned object is placed at 1 meter distance from the mirror. So as we are taking that backline sign conventions, will get that -1. It is the -1. Therefore, shortcut formula we can take that. M is equal to F divided by M is equal to F divided by F minus U. Or M is equal to height of the image divided by height of the object, that is equal to F divided by F minus U. So height of the image is to be calculated. We have to bring this H go to right side. Height of the object is equal to, height of the image is equal to F divided by F minus U into H naught. F minus U into H naught. So then Hi is equal to F is F divided by F minus U into H naught. So height of the image is equal to F is how much? F is equal to -10. F is equal to -10 divided by -10 minus of minus. What is that? 1 meter means what? 100 centimeters. Minus 100 centimeters it is. Minus 100 centimeters. Minus 100 centimeters. That is. So this will be equal to, we'll write -10 divided by into Hy is there, into H. Height of the object is given 5, right? So that is equal to 50 divided -50 divided by 90. Minus or plus 90. This is plus minus. Minus only will come. 0 get cancelled. Height of the image will be equal to -5 divided by 9. Minus it shows that it is a inverted image. So 5 by 9 will be equal to 0.55. 0.55 centimeters. 0.55 centimeters. So Hi is equal to minus 0.55 centimeters. So that means the image will be like this. Inverted image it is. Next. The relation between, that I have explained, relation between the linear magnification M, the object distance U, and the focal length F is. So just I have explained, as I have explained that formula, M is equal to F by F minus U. The relation between the linear magnification, the object distance U, and the focal length F is M is equal to F divided by F minus U. Like if you go for the lenses, in the case of the lenses, refraction, we take that. Refraction, whenever we take refraction, if you take that, first to speed of the light in air, it is taken as air. Speed of the light in air is 3 into 10 power 8 meters per second. Speed of the light in water is 2.25 into 10 power 8 meters per second. Speed of the light in the glass is 2 into 10 power 8 meters per second. Like that it will be there. Now, Speed of the light it is more, it is called as the rarer medium. If the speed of the light is more, the medium is called as the rarer medium when compared with that this one and this one. So air is optically rarer than water and glass, and glass is optically denser than air and water. This is. Then refraction, it takes place when the light ray travels from one transparent medium to another transparent medium. Let us suppose the light ray travels from air medium to the glass medium. Let us suppose the light ray travels from air medium to the glass medium. It is taken as air medium, called as the rarer medium. It is taken as the glass medium, called as the denser medium. This is the incident ray. This is the incident ray, and this is the refracted ray. If the light ray travels from the rarer medium to denser medium, the light ray bends away from it towards the normal angle of incidence and angle of reflection. Deviation delta is equal to I minus R. Deviation delta is equal to I minus R. So when the light that travels, a ray of light that travels from the denser medium, this is called as the denser medium, nothing but glass medium I have taken. It is the glass medium called as the denser medium. This is air medium called as the rarer medium. If the speed of the light that instant, speed of the light that instant on it, speed of the light that instant at an angle called as angle of incidence, then the refracted ray will be like this. This is that refracted ray. Angle of refraction. Angle of refraction is greater than angle of incidence. So let us suppose this is the air medium and called as the rarer medium. This is the glass medium called as the denser medium. If the light ray that travels from the rarer to denser or denser to rarer, whatever it may be. So this light ray is traveling from the rarer to denser. Light ray that is entering from the rarer to denser or denser to rarer. In such case, angle of incidence is equal to 0. Then angle of refraction also will be 0. Here it is traveling from denser to rarer. Angle of incidence is equal to 0. Then angle of refraction also will be equal to 0. Angle of refraction also will be equal to 0. Then whenever we take that deviation, delta is equal to 0. When the light that travels from one transparent medium to another transparent medium, it bends at the boundary of separating two media. It bends at the boundary of the two media. Then it is called as the refraction. The phenomenon is called as the refraction. So refractive index mu is equal to sin I divided by sin R. Refractive index mu is equal to sin I divided by sin R. Or if you take that refractive index mu is equal to speed of light in air or vacuum to the speed of light in a medium. So the speed of light in a medium, V is equal to n lambda, we may write. V is equal to n lambda, we may write. So refractive index mu is equal to C divided by n lambda also we may write. This is, and instead of n lambda, we write f lambda, f for frequency. V is equal to f into lambda. So mu is equal to C divided by f into lambda. This is refractive index mu is equal to C divided by f lambda. Like this we may take. Whenever we take that, a lens formula, lens formula. We'll take that. 1 by F is equal to 1 by V minus 1 by U. This is the lens formula. Lens formula or magnification. M is equal to V divided by U. Magnification M is equal to V divided by U. This is the lens formula. So shortcut formulas are also there for this lens. M is equal to F divided by F plus U, or M is equal to F minus V divided by F. Like this we will write. Right? This is the one case. Whenever that observer is there in the rarer medium and the object is there in the denser medium. Observer is there in the rarer medium and the object is there in the denser medium. Then for that it appears, the object appears less than that of its actual depth. For example, a bird is there. For example, a bird is there on the tree, one bird is there, right? In the water, one fish is there. In the water, a fish is there. A fish is there in the water. For the bird, fish appears less than that of the actual depth. Fish is there in a denser medium called as the water medium. Bird is there in the rarer medium. For the fish, bird appears less than that of its height. And for the bird, fish appears less than that of its actual depth. And for the fish, bird appears more than that of its actual height. For the fish, bird appears more than that of the actual depth, actual height. Right? This will happen. That we called normal shift. So this is a normal shift whenever we take that. First case, observer is there in the rarer medium and object is there in the denser medium. So delta H is equal to H into 1 minus 1 divided by mu. H into 1 divided by 1 minus 1 by mu. So delta H is equal to H into 1 minus 1 by mu. This is delta H is equal to H into 1 minus 1 by mu. This is the normal shift when the object is there in the denser medium and observer is there on the rarer medium. Whenever we take that, for fish, bird appears more than that of its actual depth. More than that of its actual depth it appears. So we will take that. Delta H is equal to H into mu minus 1. Delta H is equal to H into mu minus 1. Right? This we take it. Next. Critical angle. When a ray of light that travels from one transparent medium to another transparent medium, let us suppose it is moving from the water to or glasses to say glass to air. It instants from the glass to air, instant light ray. This is the instant light ray. So for this instant ray, This is that refracted ray. This is the refracted ray. If the light ray that instant like this, if the light ray that instant like this, angle of incidence will be like this. Angle of incidence is taken as I1. Here angle of incidence is taken as I2. I1 is greater than I2. This is R1, R2. So I1 is greater than I2 and R2 is greater than, sorry, I2 is greater than I1, as well as R2 is also greater than R1. R2 is also greater than R1. In such case, if the angle of incidence further it is increased, for the angle of incidence, it is that incident ray, for the angle of incidence which makes angle of refraction, angle of incidence I is there, angle of refraction which makes 90 degrees, angle of the refraction is equal to 90 degrees. This is called as the critical angle. If the incident light ray angle of incidence is greater than critical angle, it will get total internal reflection. It will get the total internal reflection. This is the critical angle and total refraction relation. So critical angle sin C is equal to 1 by mu. Sin C is equal to 1 by mu, or C is equal to 1 divided by sin inverse of mu. Sin inverse of mu, like. So when the two lenses, let us suppose this is a convex lens. This convex lens consists of the focal length f. What is the power of the lens? Power is that reciprocal of the focal length. Power of the lens is 1 by f. If focal length is in meters, power of the length is power of a lens is 1 by f in meters. Its unit is diopter, or we'll say that per meter. D for diopter. Or power P is equal to 100 divided by f. If a focal length is in centimeters, a power P is equal to 100 divided by f. Its unit also diopter or per meter. So 100 divided by f. It is called as divided by f. It is called as that power. When the two lenses they kept in contact, two convex lenses they kept in contact, the effective focal length will be. They kept in contact. F1 and F2 are the two lenses. So effective focal length will be 1 by f is equal to 1 by f1 plus 1 divided by f2. 1 by f1 is equal to 1 by f is equal to 1 by f1 plus 1 by f2. So 1 by f is equal to, if I take f1, f2 LCM, so 1 by f is equal to f2 plus f1 divided by f1, f2. Therefore, f is equal to f1, f2 divided by f1 plus f2. F is equal to f1, f2 divided by f1 plus f2. This is the effective focal length. This is called as effective focal length of this. Power, if you want to calculate, power P is equal to, power of this one is taken as P1, power of this one is taken as P2. So P1 plus P2. We have to take. Let us suppose he has given focal lengths of the two lenses and asked to calculate what is the effective power. Direct formula, we can use it. So that two lenses they kept in contact, their focal lengths are given f1 and f2 and asked to calculate the power. Power P is equal to 100 divided by f1 plus 100 divided by f2. So P is equal to 100 divided by f1 plus 100 divided by f2. This is the case. Then refractive index of material of the prism. Refractive index of material of a prism. So let us suppose a prism. If the light ray that incident on the prism is like this, refracted ray and emergent light ray, that will take. Refractive index of the material of the prism mu is equal to sin A plus dm by 2 divided by sin A by 2. Sin A plus dm by 2 divided by sin A by 2. This is the refractive index of the material of the prism. This is the refractive index of material of the prism, which is fine. This is refractive index of the material of the prism, which is. Then we'll see the problems. Light has a frequency. A light has a frequency 4 into 10 power 14 Hz and wavelength 5 into 10 power minus 7 meters in a medium of refractive index. In a medium, the refractive index is, I gave you the formula for the refractive index. Mu is equal to C divided by V, or mu is equal to C divided by F lambda. What is the speed of the light in air or vacuum? 3 into 10 power 8. It is given that frequency is given as F is equal to 4 into 10 power 14. So when the light travels from one medium to another medium, wavelength changes, focal length, wavelength changes, and velocity, speed of the light that changes, but the frequency remains the same. When light travels from one medium to another medium, frequency remains same. That you have to keep it in mind. Then wavelength is given. Wavelength is given how much? 5 into 10 power minus 7 meters. Then refractive index mu is equal to 3 into 10 power 8 divided by 4 into 10 power 14 into 5 into 10 power minus 7. Therefore, mu is equal to, this is 3 divided by 4 5s are 20. 20 into 10 power 8. So 10 power minus 7. So then mu is equal to 3 by 2, 3 by 20. 3 by 20 into 10 power 8 to 10 power minus 7. It will be equal to 10. So mu is, these two gets cancelled. Therefore, mu is equal to 3 by 2 or 1.5. 1.5 it is. Mu is equal to 3 by 2 or 1.5. This is the refractive index. Next. When light goes from air to water, the quality that remains unchanged is, frequency. The physical quantity which remains is called as the frequency. Next. When a light refracted air to glass, when the light is refracted air to glass, then its wavelength decreases but the frequency remains same. Its wavelength decreases but the frequency remains the same. Next one. This is the different media. mu1, mu2, mu3, mu1, mu2, mu3, mu4, like that it is there. What is the relation? mu1 and mu2, mu4 relation, mu4 relation, if you take that. First medium and last medium, if they are same. First medium and the last medium, if they are same, AB and CD will be parallel. If the first medium and last mediums are same, then AB and CD will be parallel. They'll be parallel to one another. Then otherwise we'll say that AB is parallel to CD. In such case, refractive index of the first medium is equal to refractive index of the fourth medium. It is a repeated problem. It is given that the surfaces of all media are parallel. So the surfaces of a media are parallel. then mu1 is equal to mu4. We have take mu1 is equal to mu4. Fourth option is correct. Then critical angle of light passing from the glass to air is the minimum for violet. Critical angle when the light is traveling from the glass to air is minimum for violet. A diver at depth 12 meters in water, its a refractive index is 4/3, sees the sky in a cone, vertical cone. A fish or the divers in the water, they'll see the outside world, in a conical shape of area of cross section A. They'll see a conical shape of area of cross section A with the vertex angle 2 theta or 2c. With the vertex angle 2c, they will see that, they'll see that semicircular zone like that, we'll say that. So that sin c is equal to 1 by mu. Sin c is equal to 1 by mu. Then c is equal to sin inverse of 1 divided by mu. Sin inverse of 1 by mu. This refractive index is given as c is equal to sin inverse of, what is the refractive index? 4/3. 4/3 means it becomes 3/4. 1 by 4/3 actually. What is that? 1 divided by 4/3. Then c is equal to sin inverse of 3/4. Sin inverse of 3/4. Next. The phenomenon utilized in optical fibers is total internal reflection. The phenomenon that is used in that optical communication is a total internal reflection. That's called as the total internal reflection. So these lenses, when the convex lens of focal length f is cut into two equal parts, it will be equal to 2f, it will be equal to 2f. Its focal length is 2f, its focal length is 2f, its focal length is 2f, and its focal length is 2f. So how to simplify this? 1 by f is equal to 1 by f1 plus 1 by f2. 1 by f1 is 1 by 2f, is 1 by 2f. So 1 by f is equal to, if I take the 2f common, LCM, 2 do get cancelled, 2 get cancelled. Let us suppose, so f dash is equal to f. So there will get 1:1:1. For this, the focal length ratio will be equal to 1:1:1. Its focal length is f, combined focal length is f, its focal length is also f. 1:1:1, we take it. It's complete, right? I'm going to stop the class here. We'll see that remaining problems in the next class. Thank you.